My dear students, today I am going to discuss maths for class 9 and 10. In class 9 and 10, you have learned about polynomials of different type: linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial of different degrees. And also you have learned about their factors and zeros. And then in class 9 you have learned this factor theorem, which is very important, factor theorem. Now what I am going to discuss today requires some knowledge of factor theorem. Therefore let me help you recollect this factor theorem. Now this factor theorem has two parts. First part says, if a is a zero, if a is a zero of the polynomial px, then x minus a must be a factor of the polynomial. If a is a zero of the polynomial px, suppose polynomial is px, where variable is x. If a is a zero of the polynomial px, then x minus a must be a factor of the polynomial. Now the second part says just the reverse. If x minus a is a factor, if x minus a is a factor of the polynomial, this px, alright, then a must be 0. Then a must be 0. So you see they are reverse of each other. So these are the two parts of factor theorem. If a is a zero of the polynomial px, then x minus a is a factor. Now this a means plus a. This is plus a, therefore it is minus a. If it is minus a, then it will be x plus a is a factor, opposite. So if x minus a, second part is what? If x minus a is a factor of polynomial px, then a is a 0. Now again opposite, this is minus a, therefore this is plus a. Plus a is 0. If it is x plus a, then it will be minus a is 0. Clear? So these are the two parts of the factor theorem which we learned in class 9. Okay. Now let us see a problem. Now suppose there is a question. This polynomial is given x square minus x minus 6. This is a polynomial px. This is px. Okay. Now 1 0 is given. 1 0 of this polynomial is given. 1 0 is suppose given 3 is 3. 1 0 is given 3. You have to find the other 0. Now this is a quadratic polynomial. It has 2 zeros. Cubic polynomial has 3 zeros. Biquadratic polynomial has 4 zeros, like that. So this is a quadratic polynomial. It has 2 zeros. So 1 0 is given 3. You are supposed to find. You are asked to find the other 0. Okay. So what is the method? Simply, first of all, we use the factor theorem. Now since 3 is a 0, since 3 is a 0 of the polynomial px, therefore we use the first part. You see, if a is a 0, then x minus a is a factor. Now here it is given 3 is a 0. Therefore what do you conclude? Therefore x minus 3 is a factor of the polynomial. Is a factor of the polynomial. Now this is plus 3. Therefore opposite, minus 3. So plus 3 is given as 0 of the polynomial, this one. Therefore minus 3. X minus 3 is a factor of the polynomial. Okay. Now the method says you divide this given polynomial x square minus x minus 6. You divide by what? This x minus 3. You divide by x minus 3. Okay. So if you divide by x minus 3, long division, so you will get x first. So x square minus 3x. So if you subtract, what you will get? This will become plus. So it will be 2x minus 6. 2x minus 6. Okay. Now you have to put plus 2. If you put plus 2, you will get 2x minus 6. 2x minus 6. So remainder 0. So we have got this is a factor. This is a factor of the given polynomial. Now this is a quadratic polynomial, so it has two factors, 2 zeros. Now which two factors? X minus 3 is a factor, x plus 2 is a factor. Okay. Now since x plus, now we use the reverse, the second part of the factor theorem. So if x minus is a factor, then a is 0. Now what we got? You see, x plus 2 is a factor. Therefore, from here what we conclude? Minus 2 is 0. Is 0 of the polynomial. Now this is plus 2. Therefore, you have to take the opposite. Minus 2 is a 0. So we got our answer. So our question was 1 0 is given 3. Find the other 0. So we divided and all that. This is the method. So we got the other 0, minus 2. So 3 and minus 2 are zeros of this quadratic polynomial. Okay. Alright, now let us see one cubic polynomial. Let us see one cubic polynomial. Suppose this one. Cubic polynomial. Say px equal to, say, 2x cube minus 3x square minus 2x plus 3. So this is a cubic polynomial, highest degree 3. Now it will have 3 factor and 3 zeros. Now 1 0 is given. 1 0 of this polynomial given, and that is equal to 3 by 2. 3 by 2, which is a given fraction. So the question is, find the other 2 zeros. Find the other 2 zeros. This is the question. So this is a cubic polynomial, so it has 3 zeros. So 1 0 is given, this plus 3 by 2. Okay, so find the other 2 zeros. Now as the method says, what we do? So we use the factor theorem. Since this plus 3 by 2 is a 0, of the given polynomial, alright, therefore x minus, this is plus, therefore we take minus, x minus 3 by 2 is a factor of the given polynomial. So we are using the first part of the factor theorem. Since plus 3 by 2 is a 0 of the polynomial, therefore x minus 3 by 2 is a factor of the given polynomial. Now with this, by this factor, we are supposed to divide the given polynomial. That is the method. But before dividing, let us simplify. This is a fraction. In case of fraction, you must simplify the polynomial. How will you simplify? LCM 2x minus 3. Okay, 2x minus 3 is a, so this is a factor, therefore this is a factor, therefore 2x minus 3 is a factor of the given polynomial. Now we ignore this 2. So 2x minus 3 is a factor of the polynomial. Now why we do this? Because it will be easy to divide the given polynomial by 2x minus 3 rather than by x minus 3 by 2, isn't it? This is why you simplify. Now as the method says, so by this 2x minus 3 we divide the given polynomial. Twice x cube minus 3x square minus 2x plus 3. Okay, so we put first x square into 2x cube minus 3x square. Alright, then you see exactly same cancel, so minus 2x plus 3. Okay, now we put minus 1, so you get minus 2x plus 3, so remainder 0. So this is a factor. So this was a factor. Now we got this quotient. This is also a factor of the given polynomial. Now this is a quadratic polynomial. You see, quadratic polynomial, so we can further factorize it. So x square minus 1 we factorize, so we get x plus 1 and x minus 1, because a plus a square minus b square formula. So we get these two factors. Now you see, we have got 3 factors. So this is a cubic polynomial, it must have 3 factors. So this is one factor, this is the second factor, this is the third factor. Okay, now we use the second part of that factor theorem. So since x plus 1 is a factor of the given polynomial, therefore minus 1 is a 0. So we are using the second part of the factor theorem. Okay, this is plus 1, therefore opposite, minus 1. So minus 1 is a 0 of the polynomial. Again, since x minus 1 is a factor of the given polynomial, therefore minus 1 opposite, plus 1 is a 0 of the given polynomial. So this plus 1 is a 0 of the given polynomial. Okay, So we got now, this is a cubic polynomial, so we got all the 3 zeros. So 1 0 was already provided in the question. This is 1 0. Next 0 we got -1, and third 0 we got +1. So these are the 3 zeros of the given polynomial. So 1 0 was given, find the other 2 zeros. So we got the other 2 zeros. So this is the answer. Okay. Alright, now let me show you this time one biquadratic polynomial. Okay. So I showed you one quadratic polynomial, one cubic polynomial. Now let me show one biquadratic polynomial, that is polynomial of degree 4. Okay. So consider this px polynomial in x equal to 3x4 plus 6x cube minus 2x square minus 10x minus 5. So this is a biquadratic polynomial degree 4. Okay. Now 2 zeros are given. 2 zeros are given. 2 zeros are given what? 2 zeros are given root 5 by 3 and minus root 5 by 3. So this is plus. So 2 zeros are given, plus square root of 5 by 3 and minus square root of 5 by 3. Okay. Now the question is, find the other 2 zeros. 2 zeros are given, then find the other 2 zeros. That is the question. Alright. Now as the method says, we use that first part of factor theorem. So since this is a 0, therefore what? X minus root 5 by 3 is a factor of the given polynomial. This is plus, so we take minus. Again, this is a 0, therefore x plus, y plus, this is minus, opposite. X plus root 5 by 3 is a factor, alright, of the given polynomial what? Px. This one. So using factor theorem we got this is a factor, this is a factor. Now as the method says, so we multiply, the product also will be a factor. Okay. Now multiply this one. So now alright, now you see if this is a factor, this is a factor, their product will be a factor. For example, let me give you, so if you have any doubt about this, let me give you an example. Now 3 is a factor of 60, 4 is a factor of 60, isn't it? 60 is exactly divisible by 3, 60 is exactly divisible by 4, so 3 is factor of 60, 4 is factor of 60. So therefore 3 into 4, 12 must be a factor of 60. That is the concept. 3 is a factor of 60, 4 is a factor of 60. Therefore 3 into 4, 12 must be a factor of 60. So that concept we are using here. This is a factor of the given polynomial px. This is a factor of the given polynomial px. Therefore their product must be a factor of the given polynomial px. That is the idea. Okay. Now we multiply these two. X minus root 5 by 3 and x plus root 5 by 3. Okay, we multiply. Now we multiply by using the formula a plus b into a minus b. So you get a square minus b square. B square means root 5 by 3 square. Alright. So what we get? A square minus 5 by 3. A square minus 5 by 3. Isn't it? X square minus 5 by 3. So that is what we get. So this is a factor of given polynomial. So this is a factor of the given polynomial. Alright. Now according to method we are supposed to divide the given polynomial by this product. Okay. Now this is a fraction, so we can divide the polynomial by this, although it is a fraction, but it will be better if you simplify this, make it into a simple linear. I mean remove the fraction. So how will you say if you want to remove the fraction? 3x square minus 5. Okay. Now this is what we got. Now according to rule, this is a factor. This is a factor of the given polynomial px. So we ignore this 3. We ignore this 3. Okay. So finally what we get? A simple thing. Now by this we are now going to divide the given polynomial. So this part you note carefully. So we try to remove the fraction like this. So ignore the 3. Now this is a factor of the given polynomial. So we divide the given polynomial now by 3x square minus 5. Okay. So 3x square minus 5. So by this we divide the given polynomial. So what is the given polynomial? 3x4 plus 6x cube minus 2x square minus 10x minus 5. Okay. So this is a given polynomial, biquadratic polynomial. So we divide by this one. So first of all we put x square. So we get 3x4 minus 5x square. So x square below x square, isn't it? Now these two cancel. So this becomes plus. So 6x cube. Then this will be plus 3x square. Then this minus 10x come down. Okay. So next we put plus 2x. So if you get plus 2x, you get 3x cube. 6x cube. 2 into 3, 6x cube. Then minus 10x. 5 into 2 minus 10x. Okay. Yes. Now this cancel. So this comes down. 3x square, and this minus 5 comes down. Isn't it? Now at last we put what? Plus 1. Plus 1 if we put, we get 3x square minus 5. Okay. So we get this quotient. So now this quotient is a factor of the given polynomial. This is a factor of the given polynomial, and this quotient is also a factor of given polynomial. Alright. Now this quotient is a quadratic polynomial, so you must factorize it. X square plus 2x plus 1. We factorize by middle term method, and we get actually this is a square plus twice ab plus b square formula. So it will be x plus 1 whole square. That means what are the two factors? X plus 1, although they are same. Two factors. So since this is a quadratic, so we got this was a result of two factors, and now 2 plus 2, 4 factors. Okay. Now we have to find two zeros. No, 2 zeros were given. Now we have to find the other 2 zeros. Now since x plus 1 is a factor of the given polynomial px, therefore using that second part of the factor theorem, minus 1 is a 0. So minus 1 is a 0. Now this is plus 1, so we take the opposite, minus 1. So minus 1 is a 0. Okay. Again. So we took this one, now we take this one. Although they are same, we must do this way. X plus 1 is a factor of the given polynomial px. Okay. Therefore, it is plus 1, so minus 1. So minus 1 is a 0. So the question was find the other 2 zeros. So we got this one, minus 1 and minus 1, although they are same. So when you write the answer, write twice, minus 1 and minus 1. You must write twice because we are supposed to find the other 2 zeros, although they are same. Okay. So this was a case of biquadratic polynomial. Now let me show you another biquadratic polynomial which is very common in exam. Actually all the numerical problems that I am showing you are very frequently given in exam. Okay. Now, yes, so let us see another biquadratic polynomial. This is slightly harder. So x4 minus 6x cube minus 26x square plus 138x minus 35. x4 minus 6x cube minus 26x square plus 138x minus 35. This is the given polynomial, and 2 zeros are given. 2 zeros are given as what? 2 plus root 3 and 2 minus root 3. So this biquadratic polynomial, 2 zeros are given, both plus. So you are asked to find the other 2 zeros. 2 zeros are given, find the other 2 zeros. Okay, that is the question. Now as the method says, using that first part of factor theorem, what we get, since this is a 0, therefore what, x minus this is plus, opposite minus, 2 plus root 3 is a factor of the given polynomial. Again, since this is a 0, therefore x minus, this is plus, therefore opposite minus, 2 minus root 3 is a factor of the given polynomial. Okay, now these two are factors of the given polynomial. Now we simplify. So first one we simplify, what we get, x minus 2 minus root 3, isn't it? We open the bracket, and this one we simplify, what we get, x minus 2 plus root 3. Okay, that means these two are what? They are factors. They are factors of the given polynomial px. Okay, now as the method says, what we have to, we are supposed to multiply these two. Now x minus 2 minus root 3 into this x minus 2 plus root 3, we are supposed to multiply. So we multiply by using a minus b into a plus b formula. This is a, this is b. So a minus b into a plus b, a square minus b square. Now what is b? B is root 3. And what is a? X minus 2. Okay. Now a minus b whole square formula, x square minus 4x plus 4, this is 3. So finally we get x square minus 4x plus 1. Okay, now since this is a factor, therefore their product will be a factor. Now their product, we got this one, so this is a factor of the given polynomial px. Okay, now as the method says, what we are supposed to divide. So we are supposed to divide the given polynomial by this x square minus 4x, x square minus 4x plus 1. So which, x4 minus 6x cube minus 26x square plus 138x, quite big, minus 35. Okay, so we are supposed to divide the given biquadratic polynomial by this x square minus 4x plus 1. Alright, so what we put first, we put, I think, x square into this will be x4, then minus 4x square minus 4x cube, then plus x square. Okay, now subtract, this will cancel obviously, then this will be plus, this will be minus, so minus 6 plus 4, that is minus 2x cube, then here minus 27x square, so we bring down plus 138x. Okay, now next we put minus 2x. So if we put minus 2x, what you get? Minus 2x cube plus 8x square, then minus 2x. So we subtract these two, cancel. So this becomes minus, this becomes plus when you subtract. So it will be minus 35x square, minus 35x square plus this plus the 140x, then this minus 35 comes down, the last term. Okay, now we put, I think, minus 35. If we put minus 35x square minus plus 140x minus 35, so remainder 0. Now we got this quotient. So this quotient is a factor of this. This is a factor of the polynomial. This quotient is also a factor of the polynomial. Now this quotient is a product of two factors. So those two factors will also be factors of the given polynomial. Now we factorize this quotient. That is the method. So note the method, learn the method. So we factorize by middle term method. I will not show you the middle term method, already you know it. So you will get x minus 7 and x plus 5. Do it by middle term method. Alright. So you will get these two factors. Okay. So now what? X minus 7. Since x minus 7, now we got these two factors. So now x minus 7 is a factor of the polynomial. This also is a factor of the given polynomial. So since x minus 7 is a factor, Therefore, using that second part of factor theorem, what we get? Plus 7 is a 0. Okay, this is minus 7, so we take opposite, plus 7. So 1 0 we got. Then x plus 5 is a factor, so since x plus 5 is a factor, so using that reverse, that second part of factor theorem, what we get? Minus 5 is a 0 of the given polynomial. So why minus 5? This is plus, opposite minus. Okay, so this is plus 5, opposite minus 5, this is minus 7, opposite plus 7. So we got the two zeros, plus 7 and minus 5. Previously we had been given these two zeros. We are given these two zeros given. Now we are asked to find the other two zeros, so we got this one, plus 7 and minus 5. So that is the answer. Plus 7 and minus 5 are the other two roots. This is the answer. Okay, so this is how you have to solve. So I hope the method is clear. So learn the method, learn the formula, learn the method. Do not learn individual sums. If you learn individual sums, you will not be able to do sums which you have not handled before. But if you learn the method, then you will be able to do any sum given from any book made by any teacher. Alright, so as I have been telling you, learn the method, learn the formula. Okay, then I hope this has been useful to you. And before I close, let me tell you one thing. If you like all these things, teaching, so subscribe to my channel. Okay, alright, good night.